Yo, what's up guys? I hope you're having an amazing day. It's Mr. You know what I mean. Alright, it's Mr. DONDW once again. And don't forget, knowledge is power. Okay, today we're going to have science, guys. Okay, science. So what are the activities, or what is the lesson for today? We're going to talk about seasons. We're going to talk about revolutions, and we're going to talk about hemispheres. Okay, so those are the ideas or the topics that we aim to unlock today. Good. All right. So first things first, let's talk about Earth's rotation. And before we go to that, let me ask you the question. What does our planet do in 1 year? Teddy, do you know the answer? Hi, Teddy. Say hi to them. Hello. That's my teddy bear. Actually, yes, Teddy. You're okay. You're okay. Just sit there. Just sit there. Okay. Anyway, that's Teddy. Oh, so going back, what does our planet do in 1 year? Okay. Now we all know. You know, guys, for sure, because you have gone through an activity of this, a project actually. It's about Earth's motion, rotation, and revolution. Okay, so I guess you know that pretty well already. Okay, now it revolves around the sun, and it takes a year, right? 365 in 1/4 days, 366 if it's a leap year like 2020. Okay, that's cool. Now, while it's actually revolving around the sun on an elliptical shape, which is, we call it, to make it clear, it's an orbit, alright? It's actually spinning. So it's spinning counterclockwise while it's actually revolving around the sun. There you go. Okay, so what's the effect of that? Well, the effect of that is basically the seasons that we have. Okay, although technically speaking, we don't have the 4 seasons. We don't have winter, spring, summer, and fall. We don't have that one, guys. Now, countries in the equator usually have 2 seasons, wet and dry seasons only. Okay, so to make it clear, I'm going to show you a diagram about how the Earth is divided into 2: the northern hemisphere and the southern hemisphere. Okay, so I'm going to show you a video right after this. And this is on page, I would like you to get your book. I would like to get your book, and it's going to be on page 90 and 91, guys, in your Cambridge textbook. So I want you to be guided. You can get your book, you can read it, and also you can use this video as your basis for you to answer the activity later on. On what page? It's actually, it's exercise 6.5 on your workbook, okay? And the title of that one is The Earth Revolves Around the Sun, exercise 6.5, guys. There you have it. So first things first, let's watch this diagram for us to learn about the seasonal changes and the northern hemisphere and the southern hemisphere, and what is the length of the day for countries that are near the equator. Fact: Indonesia is in a very tricky situation. Why? Because parts of Indonesia are actually in the northern hemisphere, and some parts of Indonesia are in the southern hemisphere. That's pretty cool. Okay, so let's watch the diagram.
Today we're going to look at patterns of day and night to answer the question, why does the length of day change from summer to winter? Let's start with some background knowledge about the Earth. The Earth is separated into 2 halves by an imaginary line called the equator. The half of Earth that is between the equator and the North Pole is called the Northern Hemisphere, while the half of Earth that is between the equator and the South Pole is called the Southern Hemisphere. There's also another imaginary line that runs through the Earth from the North Pole to the South Pole, and this is called the Earth's axis. The Earth rotates or spins on this axis, and it makes a full rotation every 24 hours. Now, let's look and see how the Earth and Sun relate to each other. What causes day and night? Well, the half of Earth that is facing the sun is illuminated by the sun's light, and in that half, it's daytime. The half that is facing away from the sun is in darkness, and it is nighttime in that half. Now, in this diagram, the Earth's axis is straight up and down compared to the sun, but that's not actually what the Earth looks like. If this were true, almost everywhere on Earth would be in the light for half of the day and in dark for half of the day, meaning that they would have equal days and nights all of the time. But the Earth is not straight up and down. It is tilted at an angle of 23.3 degrees. Because of this, the northern hemisphere is pointed towards the sun at this time of year. In this picture, it's June. What do you notice about the amount of light compared to the amount of darkness now in the northern hemisphere? Well, the northern hemisphere now is getting a lot more sunlight than it did when the Earth was straight up and down. This means that the days will be longer than 12 hours. It's also a lot less darkness in the northern hemisphere, meaning the nights will be shorter than 12 hours. In the northern hemisphere, this is our summertime. The northern hemisphere is not always pointed towards the sun, though, because the Earth also revolves around the sun. It takes 1 year or 12 months to complete one full orbit. In this diagram, the Earth only completed half of its orbit, so that would only be 6 months after June, which is December. Now, in December, the northern hemisphere is now pointing away from the sun. The side closest to the sun is in daytime, and the side facing away is nighttime. Let's compare the amounts of sunlight and darkness in the northern hemisphere now that it's December. The amount of darkness is now much greater than the amount of sunlight that the northern hemisphere receives. This means that the days will be shorter during December and the nights will be longer. In the northern hemisphere, this is winter time.
So we're done with the nice presentation video. Okay, so it's time for evaluation, guys. Okay, we're going to answer this one. It's on exercise 6.5. The Earth revolves around the sun. Okay, so I think you can see it clearly now. So you have to answer the following question based on the diagram here. First question, which hemisphere is having summer? I think you know the answer. Don't forget to write it here. Okay, explain your answer. How are you going to explain your answer? Basically, you have to, of course, explain that it is what? Facing directly. Alright, good. Bigger portion of the northern hemisphere is facing the sun. That's clear, guys. So it's really important to watch this video because you will not be able to get the correct answer, right? Okay, now number 2. Estimate the length of the day experienced by people living in X here. Oh, it's the equator. Alright, in the equator. So basically, if you are in the equator, you will experience approximately 12 hours of daytime. And at the same time, 12 hours of nighttime. So that's going to be the thing in the equator. Yes, it's boring. No, it's not boring, but this is how it works. Okay, so let's proceed. What time will the sunrise be and the sunset on X? I guess you pretty know the answer. So you have to make your own observation. Alright, so you try to observe it, but pretty much the same actually. It's going to be around 5:30 in the morning and around 5 or 6 in the afternoon. Alright, sunrise will be at 5:30 and sunset will be approximately around 6 or 5:45 in the afternoon. Okay, now if you live at Y here, okay, would you need to, or is the thick coat outside? I'm gonna leave you with this one because I know pretty well that you know the answer, right? So remember on the video,
This portion of the northern hemisphere receives more sunlight. What about this portion here on white? Okay, so I guess you have to answer on your own. And also you have to explain why or why not. It's actually on the southern hemisphere, alright? Near the south pole, alright? And which month of the year does this diagram represent? Okay, so I guess you know the answer. Alright? So guys, please don't forget to submit your work, photo or take a photo of this one, alright? With your answer of course, and send it to this one. Once again, enjoy the rest of the day. It's Mr. DOMBWE now signing off. Bye.